Welcome back to the Y.E.S Longevity Podcast, Functional Longevity Podcast, pardon me, where we give you insight on how to get fit, feel younger, and live better. Hi, I'm Chris Borda, owner of Y.E.S Fitness, best-selling author of Get Stronger, Live Longer, the expert's guide to strength training for longevity. I want to thank you for taking some time today to listen to what I have to say. I got a great topic for you today, but before we get to that, I just hope that everyone had a great holiday weekend. I know it was a little bit rainy. Despite the rain, I think everyone that I talked to really enjoyed having 3 days off, a little bit back to normalcy without the masks, and ready to move forward, which we are ready to move forward ourselves as well. We have no housekeeping right now, so where we're headed today is scientific breakthroughs. 5 scientific breakthroughs for longevity. So as I go along here and continue to study how to help people extend their health span, I constantly find that there's just no one answer, but many different answers. So what we try to do today is I'm going to try to put together the 5 latest scientific breakthroughs for longevity. Some of the things we've talked about already, and some things we haven't spoken about. So I thought we'd just kind of encapsulate this into 5 things. Hopefully you can follow the science. If you don't, certainly pop up with a question. I will answer it for you. But each one of these areas addresses a different level of the biological organizations. So what I'm talking about is cells, tissues, organs, the organ system, and organisms. So let's kind of take a look at how they're going to work in the most simplistic fashion as I can here without getting too scientific, and what they're aiming to accomplish. So first up is something that we've talked about before a little bit already, is cells and the reprogramming of cells. Cells are the simplest level of the organisms, and it's just the smallest, tiniest level of all organizations, even in the living organisms. So aging at the cellular level is often defined as the accumulation of destructive changes caused to the gene expressions that gradually shift the cells to an aged state. So as that gene shifts towards the expressions get messed up, it's going to shift towards that aged state or getting older. Now this is why this is particularly exciting. There's a study published in December 2020 in Nature, and it demonstrated that it's possible to partially reprogram old cells, allowing them to regain youthful function. A team of researchers led by Dr. David Sinclair, who we spoke about before, used cellular reprogramming to reinstate youthful function and successfully rejuvenate old cells in the eyes of mice. I've talked about this before. They were successfully restoring vision to a mouse version of glaucoma. Very exciting. And aging is a degenerative process that leads to tissue dysfunction and death. A proposed cause of aging is the accumulation of epigenetic noise that disrupts gene expression and leads to decrease in tissue function and regenerative capacity. The changes of the DNA patterns over time form a basics of the aging clocks. But whether older individuals retain the information needed to restore these patterns was what was in question. What is in question. Whether this tissue could function again, improve its function, is really not known. What happens is over time the central nervous system loses function and regenerative capacity. It can no longer regenerate the cells. It can no longer split. And the process is used by the scientist in this study was called Rewiver, R-E-V-I-V-E-R, which stands for Recovery of Information via Epigenetic Reprogramming, has shown that old tissue can keep a record of youthful epigenetic information that can be accessed for functional aging reversal. In essence, if we think of our genome as that compact disc, remember those compact discs, you get to scratching it. Where does that information go? Can you regain that information? And it seems that they've been able to figure out a way to repolish that disk and get that youthful information back, basically reversing the aging of that cell. Phenomenal stuff. Very exciting. So next, we're going to take a look at tissue regeneration. So numerous cells working together towards one common goal are called tissue. Tissue and organ regeneration company called Y.E.S has shown that it can regrow functional ectopic organs in a patient's lymph nodes using cellular therapy. Y.E.S first demonstrated that all allogenic, see if I can get this right, hepatocytes are injected into lymph nodes of mice with diseased livers. This would regenerate and take over normal liver functions. The study was conducted in large mammals with equally impressive results. So liver tissue grown in pigs' lymph nodes could treat genetic liver diseases. So co-founder Eric Lagasse and his team believed this method could ultimately help people with various liver diseases, including end-stage liver disease, with clinical trials in humans set to begin in 2021. Now, with over 113,000 people in the United States waiting for organ transplants, this procedure could relieve suffering from many people. Instead of one donor's organ treating one patient, this could allow tissues from one donor organ to treat many patients. How cool would that be? Y.E.S has plans for kidney, pancreas, and regeneration ready to go. These achievements are a critical step towards whole organ regeneration that could, along with other upcoming technologies, allow us to live beyond the commonly accepted maximum of 120 years and possibly up to 200 years. So instead of one organ for one person, they've been able to figure out how to regenerate these organs, tissues, so the tissue from one organ be used for multiple people. It would put so many people's that are suffering and waiting for organs minds at ease, because they would be able to regenerate those tissues. So there's two things that are way beyond my scientific knowledge, but I thought I'd bring that to you with some words in there that I really have a hard time pronouncing, but it's out there. So number 3 is organ rewiring. That's what's next. So with 86 billion neurons in the brains, it's the most complex organ in the body. Neuralink, a company founded by Elon Musk, is trying to make the brain function even better. Neuralink is developing a brain computer that interfaces that will potentially give us the ability to control computers and smartphones with our minds. They have already demonstrated that it can record a rat's brain's activity via thousands of tiny electrodes implanted in its brain. Now, you're going to put a bunch of electrodes in my brain, probably not going to happen, but the research is out there. And along with the rat research, Musk has unveiled a pig with a coin-sized computer chip, which he describes as a kind of a Fitbit for your skull with tiny wires. And I'm putting a computer chip in my brain, but while the Fitbit is in your skull may seem fun, but hardly essential, imagine what this research could do for a person with severe age-related neurological conditions, such as dementia, Parkinson's, putting a chip in there so that they'd be able to make the body function. As you listen to this presentation, Neuralink is preparing for human trials. If these trials are successful, it first plans to use these devices to help paraplegics perform tasks like making mouse clicks on a computer. That would be amazing for these people to be able to improve their daily function with a little coin-sized device in their brains. Just remarkable. So far we've gone through cell reprogramming, tissue regeneration, and organ rewiring. Now we're going to take a look at the organ system reversal or reversing the epigenetic clock. Age-associated changes to the mammalian DNA methylome are well documented, and though thought to promote diseases of aging such as cancer. Recent studies have identified collections of individual methylation sites whose aggregate methylation status measures chronological age. It's referred to as DNA methylation clock or the Horvath clock. Now, we spoke about the Horvath clock before. Steve Horvath is the scientist who discovered the epigenetic clock. The Horvath clock is a measurement of biological age that can be used in a plethora of cell types, all different cell types we can use this in. And since it allows scientists to contrast the ages of different tissues from the same subject, whether it's an animal or a human, it can be used to identify tissues that show evidence of accelerated age due to disease. It'd be fantastic to be able to turn that back. An organ system is a group of organs working together to perform one or more biological functions. Our body is made up of basically 11 organ systems, which includes the skeletal system, muscular system, lymphatic system, respiratory system, and more. So for the first time in humans, in an article published in August of 2019, Aging Cell, Dr. Greg Fang and a team of scientists have shown that it may be possible to reverse biological aging. Participants in the trial reduced their biological age on an average of 2.5 years after 1 year of treatment. In addition to the reduction of the biological age, the participants also showed signs of immune system rejuvenation. The reduction in the biological age was measured with the Horvath clock. Remember, this clock works by analyzing gene expressions altered that change through their lifespan in a predictable manner to estimate a person's biological age. So finally, we've got organism rewrites. To rewriting that organism, the discovery of disease is more often conducted at the genome level now. There are a growing number of studies that are finding an overlap between common and rare human diseases, which further enhances our understanding of how disease develops. Wouldn't it be cool if scientists could find just one cure for all disease, all innate disease in one fashion? Looking at it from the genome level, I think that's what's going to happen. And it looks like they're zeroing in on that. Prime editing, a new generation of genome editing, can, in principle, put 89% of human disease on purview. Prime editing may allow researchers to edit more types of genetic mutations than current state-of-the-art CRISPR. We've talked about CRISPR before. And since prime editing doesn't rely on the ability of the cells to divide to help make the desired changes in the DNA, unlike CRISPR, it could be used to correct genetic mutations in cells that often don't divide, such as those in the nervous system. This could provide a cure for several previously untreated diseases such as Parkinson's and Huntington's. The search for a single cause and therefore cure for aging has been replaced with the view that it is highly complex and multifactorial processes. Therefore, the longevity breakthroughs listed above that I just spoke about are complementary to each other. Rather than just looking at one particular thing, they complement each other in our quest to put an end to the age-related diseases, those diseases that take our lives early. So let's just take a recap of the 5 newest breakthroughs in the longevity science cells. We got cellular reprogramming, tissue regeneration, organ rewiring, organ system reversing, and organism rewrite. 5 things, way beyond my scientific knowledge, but it's exciting stuff. It's in areas that scientists are really honing in on the ability to improve our health span. Now, you and I may not be privy to that stuff right now. We need to do the things we need to do in our own lifestyles to be able to improve our health span. But know and understand that science is working on this all the time and to making some great breakthroughs and some exciting things that have come down the road that may not necessarily happen. Well, they might happen in my lifetime. I think I'm going to live a long time, and it would be pretty exciting to see these things happen. So there you have it. Just some of the most recent research we have on longevity. Hope you find it interesting. You can look any of those topics up on the internet and find all kinds of information on it if you want to know a little bit more about it. And that's it. I want to thank you again for taking the time to listen to me today. I hope it was helpful, and you can find more information from me next Tuesday on our Functional Longevity podcast. We give you insight on how to get fit, feel younger, and live better. Thanks for watching.